Wow, look at that. Everybody is here. Or perhaps not everybody, but look at that nice plurality of folks that are here. That's lovely. Okay. So, welcome to class. My name is John Filesticker. If you're here, hopefully you're registered for Calc 2, Section 1 for fall 2020. This is our first meeting. I'm going to give a few more minutes for folks to arrive, set up some of my document camera stuff, and then we'll get started. That. I think the other thing we're going to need today, yeah, we'll take a quick tour around here. All right. This guy's saved. Okay. Yeah. I do think more people will continue to filter in over the next couple minutes, but since it is 8:01, I'm going to go ahead and get started. Just in case you don't know, I do record all of these lectures. So right now, what's being recorded is what you see on your in your window for Zoom. Whether you're running it in the native app or you're running it in the browser app, that's what will be recorded. So if you don't want to appear in the recordings, which will be going up on YouTube as public videos, just make sure that your video feed is off during any moment like this where I'm not screen sharing. While I screen share, you guys are safe. You can have your video feed on, you and I can communicate without any risk of that being captured. Most of the time, as we're working, you will see something like this. This is my document camera. So I'll have some blank paper here, and I'll just be, writing shit down. Like usually I'll start with something like this. Sorry, this pen is not all the way here. Come on, buddy. All right. Today, we're going to go over the syllabus. We'll talk about WebAssign. Which is where you're going to do the homework. And then we're going to talk a little bit about sections 5.5, 6.1. These are two sections that are supposed to be covered at the end of, there we go. These are two sections that are supposed to be covered at the end of Calc 1, but they don't always get covered. For example, when I taught Calc 1 over this last summer, I don't think I got to 6.1. I stopped in 5.5, and many people even stopped before that. So I just want to make sure that everybody has a kind of uniform understanding, solid background, no matter who you took Calc 1 with or when you took it. And then we're going to move into 6.2 a little bit. And that's my goal for today. So first we're going to go over the syllabus. I'll switch over to that in just a second. Then I will show you guys how the online homework goes, because that's actually where you'll be doing you'll be spending most of your time, besides, attending class and watching these videos. And then we'll go ahead and get started on some mathematics. So 0th things 0th. Oh yeah, and we need to talk about textbooks. So let's do the things. I'm pretty sure I downloaded a copy of your syllabus, but it's not there. All right, and we've got the full screen share on. So this is the syllabus for the class. You can download this. If you haven't yet, please do save a copy somewhere on your computer. My recommendation is to have a folder, maybe on your desktop or in your documents or somewhere that however you like to organize your file structure on your computer, somewhere have a folder where you dump all the stuff for this class. That way it'll be easy for you to find. Go ahead and navigate to our page here in Canvas. The home page, if you click home or syllabus, they both take you to this page because the syllabus page is the home page. And then go ahead and click here to download the full syllabus. This has some information that you need to register for WebAssign, so you'll want to have this handy today. And it's also what we're going over right now. So if you just click here, you'll have the option to save. Oh, I guess you can't see this because it's blocked by the Zoom screen sharing thing. But go ahead and select to save that file and then open it, and we'll go through it together. All right, we're going to do this somewhat quickly because we do want to get to some actual math today. My name is John Filesticker. You can call me John or Professor Filesticker if you want to. I don't really care. I know my last name's weird. Don't stress about it. This is Calc 2, of course, Fall 2020, Section 001. This is where my physical office is, although I won't be spending a lot of time there this semester. I'm working to get permission to do in-person office hours, but that hasn't happened yet. So for now, office hours are going to be on Zoom. Oh, and that's another thing we need to do today. I'll add that to our list. We need to plan some office hours. So the way this will work during the first week here, I will talk with you guys and all of my other students to make sure I can set up like 4 or 5 hours drop-in office hours per week. And it's important that everybody is able to make at least one of those per week. So I'll coordinate between you guys and my other students to make sure that whatever 5 hours I choose there, everybody is able to make at least one of those per week. And then if you want to meet outside of that 1 hour that you can make, or those 5 hours that I will schedule as drop-ins, you can always email me to make an appointment. Our meetings for this class are Monday, Wednesday, and Friday from 8 to 9:15. I know one of those is officially a lab meeting, but the way things are structured right now, the lab meetings are going to be very similar to the lectures. Certain days we will do special things for the lab meetings, but for the most part, just think of this as a Monday, Wednesday, Friday, 8 to 9:15 class. The final exam is on 12/7 at 8 a.m. So I think this is a Monday, yeah. So it's not horrific, but you might want to add that to your calendar. The prereqs are what they are. The textbook is Stewart's Calculus. We're on the 8th edition now, and it's important that you use the early Transcendentals version. The ISBN 13 is here if you want to search that on Amazon. My suggestion would be to try and locate a PDF. Right, I have a really nice indexed PDF here that I found for free way back in the day when I was a student. These are still all over the internet. But this is what the book looks like. So if you want a hard copy of the book, it's not a bad idea to get a hard copy too. I have a hard copy, and it's nice to be able to flip through. But they're expensive, you know, they're crazy expensive. So if you're having a hard time finding a copy of the book that you're happy with, WebAssign will give you access to an electronic copy, but it's not as nice as this PDF. It doesn't have this indexing over here, and you can't flip page to page very easily in it. If you want a better electronic copy, or you're having a hard time finding a satisfying physical copy, send me a message on Canvas or an email, and I can help you get a hold of something like this. Really?
Good morning, sir.
Good morning, yeah. So let's see. This says that we should be seeing this. Okay, is that better? Sorry, so I got a message in chat saying that we're just seeing the document camera. All right, my bad. So here's the textbook. Whether you get a physical one or an electronic one, this is what it will look like. You don't need to go out and buy a text because your WebAssign access code will give you access to an electronic form of the text. But personally, I hate the electronic form of the text that WebAssign gives you. It's locked down in a browser, and it doesn't have this nice indexing. So if you want a better electronic copy, or you're having a hard time finding a nice cheap physical copy, reach out to me through Canvas or email. I can help you find one. I can help you find a PDF like this, or I can help you locate a cheap physical copy. There's a bunch of places around town and online that have them. So that's the text. It's important you get the early Transcendentals version. That's critical. So if you want to search for it, search by ISBN. The WebAssign access code. So WebAssign is kind of like My Math Lab or My Open Math. It's this online math homework platform. You will need to buy an access code to get you into WebAssign. And then in order to register for our course in WebAssign, you need to use this class key. If you don't have an access code yet, you can still go in and register for our course in WebAssign using the free trial period. So just act as though you've bought an access code, sign in if you have an account, or if you don't have an account, go to WebAssign and create an account. The URL is just webassign.net, and you can follow the link that I put here in Canvas. So once you come to webassign.net, you'll have an option to sign in, and then you can register using a class key. And it will ask you for an access code at some point. But if you don't have an access code, when you get to the part where they ask for the access code, just scroll down to the bottom of the page and look for the option to use the temporary access. That will get you by for 2 weeks. After 2 weeks, though, they will kick you out if you don't get an access code. So this is the one thing I actually really need you to buy, is a WebAssign access code. Think of that as taking the place of the textbook. And then if you actually want a nice copy of the text, like the one you just saw me flipping through, go ahead and reach out to me and I can help you with that. So make sure you buy a WebAssign access code. Make sure you do that within the next 2 weeks. If you don't have an access code within the next 2 weeks and you use the temporary access, you will get kicked out. If you get kicked out, that means you can't keep up with the homework. And keeping up with the homework is probably the most important thing for staying on top of this class. Calculator policies. So I used to say you can use any scientific calculator as long as it doesn't do a few certain things, but the department has been cracking down on that. So if you want to use a calculator on a test, it has to be the TI-32XS. Gotta be this guy. That's the only calculator we're allowed to let you guys use on tests. You won't need a calculator. The problems are going to be prepared in such a way that the arithmetic is never challenging. So don't stress on that. Okay, yeah, cool. I'll talk with you about that maybe at the end of the meeting, Angelica. So graphing calculators are absolutely not allowed. Calculators capable of symbolic manipulation, like the TI Inspire Cast, those are definitely not allowed. If you want to use a calculator on a test, this is the only one that is kosher. But you won't need a calculator. You won't need one. There will be times where I encourage you to use Desmos or other graphing software when working through the homework. But for the purpose of the test, you'll never need a calculator. If one makes you more comfortable, though, this is the one to go with. Other stuff you'll need, of course, is a computer, modernish web browser, working internet, working webcam. If you don't have a webcam right now, you're not using one or whatever, that's fine, of course. But the exams in this class are proctored with HonorLock, and that requires you to have a decent working webcam. If you don't have one, the college can, I think, lend certain hardware. I don't know if they have webcams to lend out right now, but I know that they do have loaner laptops. So if you don't have access to any of these things, just let me know and we can work together to make sure you get access. So this is Calc 2. In Calc 2, we're going to pick up where we left off in Calc 1, which means you stopped at integration. You learned a few tricks for integrating. I'm going to teach you a bunch more tricks for integrating. So the main topics are integration techniques, applications of integration. Then we're going to talk about sequences and series and power series. This makes up the part of the course that people are afraid of, for the most part. Sequences are lists of numbers. Series are what you get when you add up elements, lists of numbers. And then power series are kind of like series, but with variables in them. So those tend to scare people. Chapter 11 is definitely the reason this class has the reputation it does, and that's like the middle third of the course. And then the last third of the course talks about things like parametric curves, polar coordinates, and certain other application things. If you click this link, it'll take you to the Santa Fe page where they list all of the objectives for the course. Technology stuff, just don't be rude. This is pretty self-explanatory. Attendance, Zoom automatically records who comes and who goes and when they come and when they go, so you don't need to worry about signing in or being counted as here. But I'll be keeping record of that. every day for the first couple weeks for financial aid purposes, and then after the first couple weeks, I'll just make a note of it when I see something that needs addressing. But there is no attendance component to the grade. You know, you miss a class, I'm not going to take any points off. But it's really encourage you to not skip class. Skipping class would be a bad move. Calc 2 moves fast. It's a hard class. So you need to stay on top of it. Makeups. Try not to miss things. If you do miss something, talk to me, preferably ahead of time, and I'll work with you as much as I can. If you miss a test, we need to schedule the makeup within a week. I'm not going to argue with you about why you missed the test. I just want to see what you know. But you need to give me some sort of explanation as to why you missed, and then we need to schedule the makeup as quickly as possible. I'm pretty cool about late work or things that you forget to hand in. Just communicate with me and I'll work with you. But after the final, things are pretty much set in stone. So I can't take anything after the day of the final. Homework and study guides. So these are important. This is where the majority of your time is going to be spent. Every single week, there will be a homework and WebAssign. So I can show you what my class last semester looked like. Am I showing these? Yeah, that's full screen. All right. So here it is. So this is my Calc 2 class from the summer. And every week, there's a new homework set. The homework sets are pretty long, you know, 20, 30 problems, depending on what it is that we're covering that week. The problems are not necessarily easy, and they're going to take some time. And then before each test, I'll put out a special assignment called a study guide. And I'll try to do that over at least a week before the test. Those will be fairly short. Those will have somewhere around 10 problems, 15 problems. And you guys need to write out nice, neat, legible solutions to all the study guide problems. The purpose there is that you can discuss those solutions with either your classmates, and I strongly encourage you to set up a GroupMe or a Discord or something like that where you guys can chat and talk about how you're solving problems, but also with myself, right? I also want you to bring those by office hours. And I want us to have an opportunity to talk and see what each other's work and expectations are like. You can show me your work, and I can give you some feedback and let you know how I would grade those if they were test problems. And you want to do that before the test. The idea being you will then not be surprised by my standards for things like neatness, you know, legibility, notation. So lab meetings, we don't have our normal lab structure, but I'm going to try and incorporate a little bit what I usually do. Usually during regular semesters, my labs involve students coming out to the board to solve problems, homework problems usually, and then talking about those solutions. And usually I let people earn extra credit. So I'm going to try to do something like that with this class in Zoom, maybe using some breakout rooms, but I haven't structured it yet. So for now, don't stress about this. As I get a little bit firmer idea how to handle labs in this hybrid setting, we might do a little bit more stuff like that. And then exams. There are going to be 3 midterms and 1 final. So the midterms are going to be in Canvas, proctored by HonorLock, and the final will probably also be in Canvas, proctored by HonorLock. The tests are during class time. The midterm tests, the regular midterm tests, just like if this was an in-person class, you come in, you sit down, you take the test during class time, and then you go home. The tests, the midterms will be during class time here. I'll probably add like a 30, 45 minute window on either end in case you have like computer problems or something of that nature that needs to be sorted out. But both the study guides and the exams, you are required to scan all of your written work in and submit on Canvas. For the exams, you do that right after you finish the exam. Study guides, that's how you hand in the study guide. So for both of these things, you'll need a scanner app on your phone or a physical scanner. The one I've been using is Cam Scanner on my phone. I like it quite a bit. It produces really high quality images if you take a little bit of time to tweak them within the app. But I'll talk more about that when we get closer to the first test. All right, so recording notice. I do record these meetings. If you don't want to be recorded, please pay attention to your video feed. Important dates, put all this shit in your calendar, like all of these. Put them all in your calendar on your phone. and add like a 1-day notice or, you know, a 1-day warning. Of course, classes started today, but this is a big deal, right? If you decide, you know, oh, holy shit, Calc 2 is, I'm just not about it right now, or fuck this professor, or whatever. Last day you can get out and get your money back is Friday. And then we've got a few holidays, Labor Day and Veterans Day. Halloween happens to be the last day you can get a W. It's spooky. Thanksgiving, it does look like the college will be closed for Thanksgiving. The last day of class is December 4th, and then your final is the 7th, and grades will be up on the 13th. This is the grade breakdown. The homework all together in WebAssign is worth about 8% of the grade, so not a whole lot. The study guides, and this is the stuff that you scan in. This is the stuff that you scan and submit to me on Canvas, your written work for the study guides, worth considerably more than the homework. That's 13%-ish of the grade altogether. So it's actually a point system, right? So the study guides are 25 points each. The homework altogether is 45 points. The midterm exams are worth 100 points each, or a total of 300 points, which is a little over half the grade altogether. And then the final exam is worth a little more than a quarter of the grade all on its own. And because of COVID-19 right now, it's a department, and I think even college-wide policy, to let the final replace your lowest midterm if it happens to be better than your lowest midterm. So that's that kind of forgiveness angle, right? If you happen to miss a midterm or really badly bomb a midterm, and then you do okay on the final, then the final grade will replace the midterm grade. The grading scale is the normal thing. 90 to 100 is an A, B plus is 87 to 90, 87 to B, and so on. And then I've got the point breakdown here if you want to calculate in terms of points. The next page of the syllabus is kind of boilerplate, required college stuff. So the jellos, this isn't something you need to worry about. It's not something that goes on your transcript, but there will be a few questions on the exams that are meant to see whether or not you're grabbing the big concepts. And then that's something we report to the state at the end of the semester. Academic integrity, this is a big deal, especially right now in the online hybrid format. I know how tempting it can be to just go Google something or to text someone when there are far fewer eyes on you watching. But please make sure that when you do your work, it's your work. And the most important place for this is in the homework, right? If you Symbolab or whatever, hack your way through the homework, then you're not actually going to learn much. It's okay to struggle. You want to struggle. You want to have those moments where it feels like, what the fuck is going on? You want to have those like sleepless nights. You want to have those moments in the shower. You're like, oh yeah, that's how it works. Like it finally suddenly clicks. And you gotta be willing to struggle to get through those. So please don't cheat, right? Just be honest. Make sure that the work you show me is yours, and that you're getting everything you can out of this. I do encourage you to read these things, make sure you know them, because if there is a problem at some point, if somebody accuses you or suspects you of having done something wrong, then you need to know how to defend yourself. And you need to be aware of exactly what it is you're expected to do and what exactly it is you're expected to not do. So read the Code of Conduct if you haven't. Americans with Disabilities Act. So if you are registered with the DRC or you intend to register with the DRC, please contact me through email and let me know what's going on. There are a bunch of different options. If you're already registered with the DRC and you have some testing accommodations set up, hopefully I received a testing contract for you, but I can't actually fill out those testing contracts until you talk to me and let me know what you want to do. Again, because of the COVID madness right now, normally we would just say, okay, well, you take the test at the testing center, but some people prefer to take the tests online and let HonorLock proctor it. Other people prefer to eschew HonorLock and use Zoom through the DRC. So if you're registered with the DRC or you have any testing accommodations or you suspect that you would be awarded testing accommodations this semester, even if you haven't registered with the DRC yet, just do me a favor and reach out to me and let me know where you are in that process, how you would prefer to handle things, and I'll do everything I can to help. Accessibility, so if you have a hard time reading the things that are written or hearing the things that are said or seeing the things that need to be seen, Note takers, screen readers, all that sort of stuff is available. Most of my documents are prepared in LaTeX, which means that they are fully functional with screen readers and all that good stuff. So if you are in need of any accessibility-ish things, again, reach out to the DRC. Discrimination, harassment, don't be an asshole. I think this goes without saying, just really seriously, don't be an asshole. Just be decent to each other, to myself, to other people at college. And student rights and responsibilities, this kind of dovetails back with the academic integrity thing. You really should know the standards to which you're being held. If people in the college can judge you according to these rules, you want to know those rules. All right, so that's that boilerplate shit, grade shit. How the course runs shit. And this is the calendar. So this week, we're going to talk about 5.5, which is substitution, 6.1, which is areas between curves, and 6.5, which is average values. I'm also going to introduce the concepts of 6.2 and 6.3, which are a little bit tricky to wrap your head around. Then next week will be 6.2 through 6.4, which is all about volumes and work. So in this week, you will be thinking like a physicist. The way that we draw things and work things out will be very similar to the way you see things done in physics 2 and 3, especially physics 3. This stuff is going to be a step back towards regular math thinking. So not a whole lot of like flux calculations or anything like that, not a whole lot of pictures here. We're just going to be coming back to pretty raw calculation. But these are all techniques for integration. Chapter 7 is all about techniques for integration. Integration by parts you can think of as a backwards product rule. Trig integrals are what they sound like, integrals involving trig functions. Trig sub is where you take an integral that doesn't have trig functions and you make it have trig functions by substituting in trig functions. Then partial fractions, you may remember from pre-calculus, is a way of splitting up rational functions. And then we'll be ready for our first test. So section 7.5 takes all of the things from 7.1 through 7.4 and wraps them into one little burrito where you have to apply all those techniques to problems you don't know which technique works best on. And then we'll have the first test somewhere right around the 5th week. After that, we're going to move into the convergence stuff, which is sequences, series, improper integrals. This stuff tends to be the hardest stuff, and this exam tends to be the lowest scoring exam. So after we finish exam 1, it's very important that you come into exam 1 ready. So if you happen to fall a little bit behind somewhere in weeks 1, 2, 3, make sure you catch up in weeks 4, 5, and that you can come out of exam 1 with a nice clear head, ready to work really fucking hard on all of the convergence stuff that comes between exam 1 and exam 2, because this is the stuff that people are mostly afraid of. This is the hard stuff. Because it has nothing to do with graphs of functions or algebra like you're used to it. We're going to be talking about discrete objects like sequences, which are lists of numbers. And then from there, we're going to talk about power series. As long as you're comfortable with series, power series is a pretty natural extension. Representing functions as power series, Taylor's theorem, which is a way to find power series for a function if you don't know anything else about it. And then we'll talk about some applications, way to find arc length, surface area, some other fun things you can do with integrals that are relevant to sciences. And then we'll talk about parametric curves, where x and y are independent of each other, but both dependent on some variable t. And polar coordinates, where you locate a point in space by telling me an angle to rotate and a distance to walk out rather than an x and a y. So that's about it. I can't think of anything else from the syllabus here that I wanted to show you directly. Are there any questions from the syllabus? So if you have questions, you can use the little hand raise react, or you can type them into the chat, whatever you prefer. All right, doesn't sound like it. So let me show you WebAssign really quickly. I'll sign out. I'll pretend like I don't know who I am. Okay, so when you come to webassign.net for the first time, it'll look like this. You're not an instructor, so I would go to login, And then if you have an account with them from a previous semester, go ahead and put those things in. Or if you don't have an account with them, you click here and go to enter class key. And this is where you would put in the class key that I give you in the syllabus. After that, it will ask you for your access code, and you would scroll down to the bottom. There's a little grayed out thing that says click here to use temporary access. That will get you in to our class in WebAssign. Right now, there isn't anything in there, but soon there will be your first homework, and that's going to be due next Monday. So that first homework, you guys are right here. So your class is going to look something like this when you sign into it. And right here will appear homework 1, you know, MAC2312 fall 20. You click that, get started on it, and try to get that done by next Monday, right? So the way the homework works in this class is I will release it every Monday, and it will be due the following Monday, right at the start of class. So this first homework will be due at 8 a.m. next Monday. It's going to cover sections 5.5, 6.1, and I guess 6.5 rather than 6.2. That's okay, but I'll warm you up for 6.2 at the end of the week. Last little bits of bookkeeping stuff. Remember the textbook. You will have a copy of the textbook in WebAssign. You can click here on the ebook. But this thing takes forever to load. It's poorly indexed. Honestly, I just hate this thing. So if you hate this thing, I understand. It has some advantages, I suppose, to a PDF. You know, they've got like embedded videos and things like that. But I'm not crazy about it. So if you hate this thing, I totally get it. Reach out to me. I'll help you find one of this thing, which I like much more. So this is where we're going to start today. But before we get to that, we're almost there. Before we get to that, we need to plan some office hours, right? So my Tuesdays and Thursdays, I think, are pretty open. Besides your class, I have another Calc 2, which is right after this one, and then a Calc 1, which is at 12:30, and then 11:40. When is that again? 2 p.m. So it looks like I do have 1 hour free between my second Calc 2 and the Calc 1 at 12:30. But I think on Mondays, Wednesdays, and Fridays, I'll most likely need that for like lunch and cleaning up. So if we wanted to do office hours on Mondays and Wednesdays, let me put some prospective office hours here. All right. If we were going to do an office hour on Monday, it would have to be after 3 p.m. After 3:15, I think, right? Yeah, after 3:15. So I could do something like 3:30 to 4:30. But I found that when I do office hours that late, people are usually not super available. Tuesdays, I could do something like 10 to 11, or 11 to 12, or 12 to 1. Wednesdays are in the same sort of situation here. I could do like a 3:30 to 4:30 if we wanted it. Thursdays are a lot like Tuesdays, so we could do 10 to 11, 11 to 12, 12 to 1, something like that. And then my Fridays are a little bit more open because I don't have this MAC 1140 class. That's just Mondays and Wednesdays. So I could do, let's see, when does that end? 1:45. So I could do like a 2 to 3. Or 3:30 to 4:30. Or like 4 to 5. I'd like to nail down a few of these. At least one that would work for folks here so we can start structuring this. So I don't know how familiar you guys are with the React options here in Zoom, but if the 3:30 to 4:30 office hour on Monday sounds appealing to you, go ahead and give me a thumbs up, React. If that's an hour that you could make and would like to attend. Okay, so there are a few folks, but not super popular. I think I saw 6 there altogether. So then let's go ahead and clear those. What about the Tuesday, like 10 to 11 hour? How do we feel about that? Same thing. Give me a thumbs up react if you could attend that. Similar numbers. The Tuesday 11 to 12? Okay, so what we're doing here is we're just giving the thumbs up reaction if you can attend this office hour. I saw a total of 5 there. How about Tuesday 12 to 1? Okay, so far this looks like a winner. Wednesday 3:30 to 4:30? Anybody want the late hour on Wednesday? Yeah, okay. 6? Yeah, okay. Okay, what about the Thursday 10 to 11? Okay, Thursday 11 to 12? Thursday 12 to 1? Okay, is there anybody who could make the 11 to 12 that couldn't make the 12 to 1? So we had more folks wanting the 12 to 1 than the 11 to 12. Anybody who could make this but could not make this? Same thing, just go ahead and use the thumbs up react if that's the case. So if you could make the 11 to 12 but could not make the 12 to 1. Okay. And then Friday we could do a 2 to 3. We could do like a 3 to 4 or a 3:30 to 4:30, 4 to 5. How do we feel about the 2 to 3 hour on Friday? Okay. All right, wow, okay, yeah, Friday afternoon's usually pretty dead. All right, I think this gives us a pretty good place to get started. So I will go ahead and add at least a few of these. I'll definitely add the 12 to 1s on Tuesday, Thursday, and the 2 to 3 on Friday. And then I'll see if my other classes, how they feel about the 3:30 to 4:30 on Wednesday. I'm a little bit hesitant to add late hours like that because I find that they're usually not super well attended. But if people really want them, then I will do them. And I'll be updating the Canvas page a little bit later in the week with the actual office hour information. So I'll put the drop-in standing office hours here, and then I'll put a Zoom link right here. Want to attend any of those hours, you will just come here and click the link. If you want to meet outside of whatever hours we settle on, you send me a Canvas message and we can set up a meeting time outside of those. Okay, so I'm going to save this stuff. And we can get started. Any other questions about the kind of bookkeepy things before we dig into some actual mathematics? Oh, so Zach asked a really good question about the library and Learning Commons. Yes, the library is open. You can go to the library. And the same is true of the Learning Commons, at least on the first. But they're not running the same way they normally run. So I don't believe it's the case that you can sit down and like raise your hand and have a tutor come over. I don't think they're doing that right now. But I do think you can go in and use the physical space. And I also think they have tutors, they're just not able to come to you physically. So if you go to the library space or the Learning Commons space and you want to work with a tutor like you might have last semester or the semester before COVID hit, then bring your laptop or sit down at one of their computers there. And I think you'll have to Zoom with the tutors, but you can go to the physical library and Learning Commons. I do think they're open. In-person office hours are something I'm trying to do. So I asked permission to do them over the summer. I got turned down. I asked permission to do them starting in the fall. I got turned down. But then just the other day, I got a notice saying that they're reserving a classroom near my physical office unit so we could do occasional brief meetings with students, whatever that means. That might mean I'm not allowed to schedule a standing office hour at that time. It might mean I can do them by appointment. So as the semester evolves and I'm able to get a little bit more feedback from my department chair and she's able to get more feedback from the administrators above her, I will let you guys know about physical, like in-person office hours. I would like to do them, but I don't know if it's going to be an option yet. The last time I asked, I was told no, but I'm hoping that that changes soon. Good questions. Any other questions about the kind of bookkeepy, syllabusy, how the course runs stuff? Okay, then let's get our notebooks. Let's get ready to take some actual mathematics notes. We're going to do a quick review of section 5.5 on integration by u-sub. Which is a little bit of a misnomer. Most of the time, I will actually use the variable z instead of the variable u, for reasons that will become clear when we talk about integration by parts. Let's try just see how much we remember. What happens if I want to substitute? Let's go for like something like this. So there's more than one way to skin this cat. This is an indefinite integral, which means that my answer is going to be an infinite family of functions, right? I'll have some function which is an antiderivative for this, and then I'll slap on a plus c, again, because this is indefinite. There are no bounds, no limits of integration, no numbers above and below this big S symbol here. And remember, when you're thinking about u-sub, you usually want to look for like an inner function and an outer function. You're trying to recognize this thing, which is the integrand, the thing you're integrating, as a composite function. I see this e to the 2x upstairs, this e to the 4x downstairs. So there's something with e to the x going on here. So one of my first thoughts might be to try and sub for e to the x. If I'm going to do that, I need to understand these pieces as pieces involving e to the x. But there's an even slicker substitution that may or may not jump out at you. Remember this algebra property of exponents? If you take some number a and you raise it to a product of powers, a to the b times c, this is really the same as a to the b all raised to the c, and that's the same as a to the c all raised to the b. So this e to the 4x, I can think of as e to the 2 times 2x. So this could be e to the 2x all raised to the 2 dx, following from this property of exponents. Does everybody see how we went from here to here? Now looking at this integral, what would be a good substitution to make? Do I have something that looks like an inner function that's showing up in some places? What would I like to get rid of there? You can hold down spacebar to talk. You can just shout out answers, that's fine.
E to the 2x?
Yeah, right, I see this e to the 2x, this e to the 2x. It looks like if I substituted for e to the 2x, something nice might happen. So let's let, maybe here I'll use the variable u, because I know that's what we're used to. Let u equal, and my u's are all curly like this, e to the 2x. What else do I need in order to make this substitution go through? How do I proceed from here?
Du.
Good, right, we need a differential. So this integral has the differential dx at the end. When I substitute in u equals e to the 2x, I need to figure out the relationship between dx and the new differential, du. And I find du by differentiating e to the 2x. What is the derivative of e to the 2x?
2e s for 2s.
Good, yeah, Hutanji got it. This is 2e to the 2x. This is a chain rule derivative, right? You differentiate e to some stuff, you always get that thing, e to some stuff, times the derivative of the stuff. So this is e to the 2x times the derivative of 2x, which is 2. So that's a chain rule derivative. Okay, so I see some good things and some bad things here. I see some things that I immediately know what to do and some things that maybe I don't immediately know what to do. I have this 2e to the 2x dx. And I need to replace this dx by some stuff involving du. So first, let me plug in the things I can immediately see what to do. Downstairs here, I've got 1 plus e to the 2x all squared. That's 1 plus u all squared, or 1 plus u squared. That part's easy. The e to the 2x up there, I'm going to move him over here with the differential. Because you see that this e to the 2x dx is actually 1/2 du. So this implies that 1/2 du is e to the 2x dx. So this piece right here, I can replace by 1/2 du. So what we get is integral 1 over 1 plus u squared times 1/2 du. So the e to the 2x upstairs doesn't actually become a u. He gets sucked into this differential term. And we need that differential term to make our substitution go through. I think this is the piece that most people struggle with a little bit as they're first learning u-substitution. It's how to incorporate the differential. A step like this is okay to write down sometimes, where you've got u's and x's, but it's important that you get rid of all of the old stuff before doing any integration. So you must, cardinal sin of u-substitution, you must get everything in terms of the new variable before doing any integration. So you can't have any x's or dx's floating around. You have to get to something like this, where it's all just u's and du's, none of the old variable. From here, I can take this 1/2. He's a multiplicative constant, so he can pop out. He'll come all the way out front the integral. The integral is a linear operator, just like the differential or derivative operator is a linear operator. And this is 1/1 plus u squared du that's left. And this might still look a little bit complicated, but if you think real hard, who has derivative 1/1 plus u squared?
Inverse tangent.
Yeah, perfect. This is the inverse tangent derivative. So this is 1/2 times the inverse tangent, or arctan, if you prefer to write arctan instead of inverse tangent like this, that's okay, of u plus c. And it's at this step where we take an antiderivative. We're no longer writing the integral symbol, so you have to start writing the plus c. So it's at the antiderivative step where you start writing in your plus c. And then the last thing to do, I was asked a question about x's. I was asked, what's the integral of e to the 2x over 1 plus e to the 4x? If I gave someone this answer, they would be confused because they don't know what the hell u is. So in an indefinite integral, you have to plug back in for u, or whatever your substitutions were at the end. So this is 1/2 inverse tangent of e to the 2x plus c, and that's your final answer. Questions on how we made this go? What works, what doesn't work, other things we could have tried, anything like that. There are several other ways to attack this problem. If you had a different idea, I would be curious to hear it.
Could we, at the du equals 2 e to the 2x step, could we solve that for dx?
You could. If you solve this for dx, so you don't need to write this down unless you want to, but you could come back to this step and say, okay, so dx is then du over 2e to the 2x, and you could try to plug all of this in. So your integral e to the 2x over 1 plus e to the 2x squared dx would be integral e to the 2x over, this would be 1 plus u squared still. And then your dx you can plug in for du. You've got du over 2e to the 2x, and you can cancel the e to the 2x's like that, and this will get you to that same place, 1/1 plus u squared times du. Yep, that works fine. My only concern or catch is if these don't cancel exactly, you'll have to think of some other way to glue this shit together. And that can be a little bit tricky. But I think what you're doing right here is just fine. The idea of solving this for dx and then plugging in, I think that's how most people first get comfy with this. And there's nothing wrong with that.
And then the 1/2 still comes out, right? Because you've got this.
Oh, did I lose a, yeah, sorry, there's a 2 here. Yeah, du over 2. Yep, so then the 1/2 would still come out. Thank you. Yep, just like that. So let's try 1 or 2 more little problems that use u-substitution. Actually, let me go to the reverse of this page. Oh, no, that's already full. All right, we'll come here. okay, how would I solve this guy? And maybe let's, yeah, let's have him run from like, no, we'll start just with the indefinite, that's fine. Any ideas how we could solve this integral? Again, thinking in terms of 5.5, thinking in terms of substitutions. Sorry, give me just 1 second here. Oh, mind, who is doing this? Bettina. Stop it, Bettina. Oh, okay. So any thoughts on how we could solve this integral? Same sort of stuff. We want to make a substitution. I've got the square root of 1 plus sine theta. And then outside the square root, I've got cos theta d theta. So the suggestion in chat was to substitute for sine x, or sine theta here, because my variable is theta. That's a workable move. I could let, and maybe I'll use the variable z this time. I could let z be sine theta, because then dz is going to be cos theta d theta. So dz is hanging out right here. And then this piece would become the square root of 1 plus z, because z is sine theta. So I like to put all my substitution work in a box, and I usually use the letter z instead of u. And I'll give you a good reason why. We're going to use the letter u very soon for something very different. So if you use u right now, it's possible to get a little bit confused in section 7.1. So Mariano has a really good observation there. First, let me go ahead and write down what we get if we use this substitution. So if we use the substitution z equals sine theta, then we'll get integral square root 1 plus z times dz. And this is a little bit easier, a little bit nicer looking than the original. So I'd say this is a step in the right direction, but we're not done yet. Right? I cannot go ahead and calculate an antiderivative from here. I want to make an important note. The square root of 1 plus z is definitely not the square root of 1 plus the square root of z. You cannot write this, you can't distribute the square root, right? Cannot like distribute the square root over those things. That doesn't. So we can't finish the integral from this step without another substitution. So now if you wanted to let u be 1 plus z, du would be, well, the derivative of 1 is 0, the derivative of z is 1, so this would just be du equals dz. And then the integral would become integral square root u. And du is dz, so this would be just du. And now we could go ahead and apply our power rule. So how would I find an antiderivative? How would I integrate u to the 1/2? I would have this power.
That means u 1/2 plus 1 over 1/2 plus 1.
Good, yeah, I add 1 to the power, and then I divide by that new power. So if I add 1 to the power 1/2, I get 3/2. And then I by that power. And at this stage, we start writing our plus c because the integral symbol is gone. This is the same as 2u to the 3/2 over 3 plus c, which would be the same as 2. And now we go back, u was 1 plus z. So 1 plus z to the 3/2 over 3 plus c. And then z, we have to go back also, right? We had an earlier substitution. So z is sine theta. So 1 plus z is 1 plus sine theta. So this is 2 times 1 plus sine theta, all to the 3/2 power over 3 plus c. And Mariana made a good observation. So first I'm going to give folks who are writing just a minute to write. Try to get this neat, but as much of the problem as we can. I swear to God, Bettina, if you don't quit spamming my email. Yeah, what Nicholas said is exactly correct in the chat there. We could combine these two substitutions together. We could have started just with z equals 1 plus theta. Then dz would still be cos theta d theta. And that would get us straight to the square root of z right away. Okay, let me take a look over here, see if we can find something a little more challenging. I would like to do a definite integral with a non-trivial differential. There has to be one here somewhere, definite integrals. Yeah, let's do that. This. So we're going to take a look at problem 69 there. You see it's got a pink number next to it indicating that it's a special problem. I'll write it down on the dot cam and then we'll come back. To integrate from e all the way up to e to the 4, 1 x times the square root of the natural log of x dx, like this. Okay. So it's a substitution problem, but now it's a definite integral. The integral has bounds or limits, those numbers above and below the long s. So our answer here is going to be a number, not a function or an infinite family of functions, just one number. It's the area underneath this from x equals e to x equals e to the 4. I'm sorry, my coworkers are, there's no nice way to say this. They're terrible with technology. I'm just going to close this so it stops making that noise. All right. Okay, so I want to look for an inner function here that I could substitute for, whose necessary piece for the differential is present, and substituting for whom would make the integral easier. So does anybody see a kind of complicated inner piece that they would like to get rid of? Yeah, the natural log, right? I kind of wish this guy wasn't here. If this guy was just an x, things would be so much nicer. Well, let's see if we can get rid of him. Before I do that, I want to rewrite this integral. So I'm thinking about substituting for ln x. I know that the derivative of ln x is 1 over x. So my differential du is 1 over x dx. And please don't skip on writing the dx's and the du's. I'll also need to change my bounds. When x is equal to e, and I know some Calc 1 professors are a little bit loose about this. They say, oh, you can change the bounds or you can go back to the original variable. Bullshit. You must change bounds. You must. No exceptions. In Calc 2, when you do a substitution in a definite integral, you gotta change the bounds every time. So when x is equal to e, what is u? Well, u is the natural log of x. So when x is equal to e, u is the natural, I'll write it all out. U is the natural log of e, which is 1. And when x is equal to e to the 4, u is equal to the natural log of e to the 4, which is 4. So to find your new bounds, you just plug the old bounds into this relationship. You say, okay, well, when my old variable is equal to the old bound, what is my new variable? So my old lower bound was e, and when x is equal to e, u is equal to 1. So my new lower bound is 1. And when my old variable is equal to the upper bound, e to the 4, my new variable u should be the ln of e to the 4, which is 4. So my new integral goes from 1 to 4. You have to change the bounds. Otherwise, the integrals will not be equal. Got to change the bounds. What else do I have going on here? Well, I've got my 1 over the square root of u. That's the 1 over ln square root ln x. That's 1 over square root u. And then I've got this 1 over x dx piece. Well, that's du. So you can write it like this, but then make sure you recognize that this is du. Because before we can actually do anything, we must get everything in terms of the new variable. So in other words, what I'm doing here is I'm taking the 1 over x square root ln x, and I'm writing that as 1 over square root ln x times 1 over x. This piece I recognize as 1 over the square root of u. This piece I group with the dx to be soaked up by this differential term. So just a little bit of side work. And then my integral is the integral from 1 to 4, 1 over the square root of u times du. So that's the substitution done. Again, I'll remind you, it's crucial that you write the differentials here, the du's, the dx's. You cannot skip that stuff. If you skip that stuff on tests, I will take off points. It's crucial that you change the bounds. When x is equal to e, u is equal to 1. So my new lower bound is 1. When x is equal to e to the 4, u is equal to 4. So my new upper bound is 4. If you don't change the bounds again on a test, I'd have to take off points. So this is what we get after implementing that substitution. I can rewrite 1 over root u as a power function. So this is integral 1 to 4 u to the negative 1/2 du. And then I'll continue this over here. If I want to integrate u to the negative 1/2, I'll add 1 to that power and divide by that new power. Negative 1/2 plus 1 is positive 1/2. So this is u to the positive 1/2 divided by positive 1/2. And then I have to evaluate between these new bounds. So because this is a definite integral and we made a substitution, we changed the bounds, you don't need to go back to your old variables. One of the nice things about me forcing you to change bounds is that on a definite integral, you don't need to then plug back in for e or do anything with e to the 4s. You don't have to plug in for ln x. You just go ahead and evaluate this new expression between these new bounds. All right, this is how we do it in Calc 2. This is how you're going to do it in Calc 3 also. The trick is to start thinking of this as a coordinate transform. And we'll be able to talk a little bit more about what I mean by that. But first we want to get comfy with the basics. So evaluate your u antiderivative between your u bounds. These are bounds for u. You don't need to go back to x's. We can simplify algebraically inside here a little bit. U to the 1/2, that's the square root of u, and dividing by 1/2 is the same as multiplying by 2. So this is 2 square roots of u evaluated from 1 to 4. So that's 2 times the square root of 4 minus 2 times the square root of 1. This is 2 times 2, minus 2 times 1. That's 4 minus 2 is 2. So this integral is equal to 2. And like we said, it's just a number because it was a definite integral. Right? Definite integrals have always numbers as their answer. Indefinite integrals have always infinite families of functions as their answer. It was a good medium hard substitution problem. Any questions on what we did here, why we did it, why we wrote it the way we did, why it came out the way it did, other things we could try, anything like that? Especially if this felt weird to you in your last class, I'd really love to hear your thoughts. We all feel nice and comfy with each of these steps, where everything came from, why we labeled things the way we did, why we changed bounds the way we did. The algebra here that allowed me to write this step like this.
Do you always want us to write out like those algebraic steps?
Like this little bit of side work here?
Yeah.
No, I just wrote this for anybody who had a hard time seeing why I did this. So I wouldn't expect you or require you to write this. It's just for folks who are having a hard time seeing where it came from. Hari asked a good question. What would be key things to review if you took Calc 1 a while ago? If I'm on top of my shit, and I think I am, then there's a module in your class in Canvas here dedicated just to that. All 20, let's see, no, that's Calc 1, Calc 2, Section 1, where are you guys? Right here, did I do this? I think I have a module full of review material. Yeah. So this module, so go to your Canvas course, go to modules, and then look at the module labeled review material. So I've got lots and lots of good stuff here. These are the main topics that I found give people a hard time in the first few weeks of Calc 2. So your basic integration stuff, and Paul's online notes is really good. If you haven't used this website in the past, I encourage you to fall in love with it. He's got all of the basic rules, like today we're talking about substitution, typeset, very nice. He talks about calculating differentials and how you make those fit into the integral. But then he also has lots of examples with solutions that you can reveal step by step. So all of these things in Paul's online notes would be a good place to start. And each one of these has exactly that. It's got a little description, some example problems, and then some practice problems. The other thing that you'll see me post a lot here are Patrick JMT videos. Patrick JMT is a math YouTuber. He does as Patrick Just Math Tutoring. I know people have a hard time with polynomial division, for example. So you can come over here, and if you would rather watch someone do it than read, in Paul's notes, you can watch Patrick divide some polynomials. So yeah, if you're a little bit nervous, if it's been a while since Calc 1, or if Calc 1 maybe wasn't super duper smooth at the end, then please look through this review material module in Canvas. Other questions about u-substitution, kind of the end of Calc 1, the problems we've looked at here? Definitely any questions about this specific problem or the other problems we've looked at? Okay, it seems like we're feeling okay. I don't see anything else in the chat. So this will be the last example we do for today. I'm not gonna push you guys through any more. Some basic advice. Make sure you always come to these class meetings. I know 8 a.m. is early. It's tough for me too Today was a groggy morning, but make sure you set the alarm and you get up and you sign in. The other big thing is make sure you take notes. Take good notes. If you ever want me to slow down while I'm writing, I'm happy to do that. But make sure you have a notebook, and make sure in that notebook you have nice organized notes that you can flip through so you can look back at examples as you're working the homework. WebAssign does have some example videos and some explanations. You can click if you get stuck on a problem and it'll try to walk you through them. But there's nothing quite like looking through an example that you wrote out yourself. So take good notes. Come to class and take good notes, just like you would if this was an in-person class. I'm doing my best to preserve the in-person class structure. And that means you need to do your best to preserve the in-person class behaviors. So take good notes, keep them organized, and stay communicative with me. What we don't have in this online setting is the opportunity to like chat on the way out the door or chat before class starts. Those little chats are a big deal. They help me get a feel for where you're at in the class and help you get a feel for what I think of where you're at and what we're doing. So whatever feelings you're having about the course, the homework, the lectures, whatever it is, I really want to encourage you to share those with me. You can send me little Canvas messages and they can be like, oh, I hate that color pen, or, I can't hear your voice so well, or can you show more algebra steps, or anything like that, any thoughts at all. Please don't hesitate to share them. I want to work with you guys and I want to make this as effective as it can be. We're going to start off with things like this that are not terribly difficult, but we're going to very quickly move towards harder and harder and harder stuff. So on Wednesday when we meet, I'm going to show you some more difficult u-substitution problems. We're going to talk about average value, which is not tricky conceptually, but the substitutions can get a little bit harder. And then on Friday, we'll sort of polish up those concepts. We'll talk more about average value and the mean value theorem for integrals. And then next week, we're going to talk about volumes. And that tends to be a tricky section. There's 6.2 and 6.3 tend to give people a little bit of a hard time. So that's what our first few weeks are going to look like. I hope that you guys hang in here, work hard. Please go back and reread the syllabus. Make sure you understand everything that's in there. Make sure you put those important dates in your phone calendar. And make sure you sign up for WebAssign. So the first WebAssign homework is going to open today and it will be due next Monday. If you have access from a previous term, like you bought a multi-semester access last summer or last spring, you may still be able to get in. You probably do not need to pay again, but I would sign into that account and try to register with a class key. So remember, the class key that you need to register is in the syllabus. This is the class key that you need to register in WebAssign. So if you're unsure whether or not your previous multi-term access will hold out, or unsure whether you need to buy a new access code, just go ahead and try to register for the class. If it demands an access code, then probably you need to buy an access code. And you don't need to do that right now. You can scroll down to the temporary access option on that page, but make sure that you do have permanent or semester-long access established before, what's the date, 2 weeks from today? Before the 7th, I think that's when they'll kick you out. And if you're having a hard time figuring out whether your multi-semester access is going to work or not, send an email to WebAssign support. And if they don't get back to you quickly, let me know. I can get on them and try to get them to be a little bit more responsive. But yeah, no, Patanji, I don't think you'll need to pay again. All right, so I'm going to go ahead and end the video here.